Hi, good morning everyone. Welcome back. In this video today, I'll talk about the system monitoring processes in Linux. This is a very important video for you to understand various system processes that are running within the Linux or the Unix system and what are the commands that you can use. These are some of the basic ones which we will talk about shortly. So in this video. So one of them is let's start with man free. So free basically tells you how much amount of memory is available in the system that is free to use, or that is basically available in the system and in the swap. And it comes with various switches which you can check over here. So let's start with this. So let's run the command free. It is saying, it is giving you the output default in kilobytes. So it says these many kilobytes is total memory, this much is used, free, shared, buffer and cache unavailable, and swap. We are not having any memory in swap. We can use some of the information in switches. So let's try. Free -h gives input in a human readable format. So total memory is 7.7 gig, out of which 502 meg is used, and this is free. Shared memory, buffer, and available balance. If you want to check your memory in kilobytes, so -k, so you'll get the similar output. That was the first output because by default it is in K. You can also check the memory in bytes, which will be more detailed. Instead of kilobytes, it will be showing you the memory in bytes. You can also check the memory in megabytes, which is -m. It will show you the memory, free. And it will show you the memory in megabytes now. So this is how it works. And then you also have gigabytes. It will show you the memory in gigabytes. And this is the total. This is the rough memory. So it is not showing you anything in decimal format. So anything and everything that is whole number is demonstrated to you. Then you also want to display that what is the total memory over here. You can use the command with -t switch. It will show you that this is the memory swap and this is the total available. You can also refresh your memory at regular intervals. So for example, -sh the switch. So every 5 seconds you want to refresh your memory. So it will show you the command that is going to swap or update the memory every 5 seconds. So this is how it works. So I'll press Ctrl+C to exit. Next command that we have is uptime, how long this machine has been on. So we'll first read the command. So I'll clear the screen and I will say man uptime. This will tell me how long the system has been running. And there are various switches that it comes with it. So let's press Q to quit and let's run uptime. So it is going to show me that I started the machine just now at 7:44. Which is the time it is showing, and it has been up since 8 minutes. Only one user is logged in, and the load average for last 1 second, 5 seconds, and 15 seconds is being displayed over here. So this is just some of the commands for memory and uptime, just to check your machine. Next important command we have is processes. So every operating system, whether it is Linux or Windows or any operating system or Unix or Mac is anyway built on Unix, they all have processes, hundreds and thousands of processes running in the background. In Windows, we call them tasks. So we have a command ps. So let's say man ps. So ps reports a snapshot of the current process. And then you have got various switches over here, which is -e, -ef, ely, ax, blah, blah, blah. And you can read through them. So let's go and do some of them. So with ps, we have got only two processes running. One is bash. This is the shell, is one of the process. And the ps command will be the new process. So if you see, you have this information. So bash has got an ID of 1295. It is running on terminal number 0, and the time and the bash command that it has been, how long it has been used for. So if I go here and run again next time also, you will see that the process ID for the process is changing because the command executed and the process killed itself. And we can come to know how long the process has been active for. So for example, if I want to see all the processes that are currently running, so ps-e, it will show you all the processes that are running, and where it shows question mark, that means some information is not available to the system. On the left hand side is again the process ID, the terminal from where it is running from, and then we have something which is known as the time, how long it has been on for or executed for, and this is the command that is running in the back. So currently I just executed the command ps. So that was the command that executed and was running from terminal 0. Then we can have more detail over here. Let's try to understand what it shows by the command over here. So we have ps-f. So these are more detailed information. So this is the user ID is Azure user, that is me. You can see here that I'm Azure user. Process ID, and this is the parent process ID for this. And this is the information which is start time, when it started, terminal that is running, and the command that it is executing. So this is bash, and the next one is ps, and the parent ID for this is 1295. So even the ps command is running from the bash process. So bash is the shell. So that is why every process has got a parent process ID as well, that where it is coming from in detail over here. Then if you want to see for a specific user, you can also run ps-u, and the user is Azure user. Now it is only going to show you all the processes that are running for specific user over here. So this means that these processes are running for me as a Azure user over here. Now we can also check, are there any processes that are running without the terminal? Then we can always check ps-x. So all these processes are running without the terminal. So some of the processes may be similar, some of the processes may be different over here. You can also mix and match the commands. You can say ps-e-f-u, and the user is Azure user, and it is going to show you all the processes that are running, full processes, and running for Azure user. So you have mixed and matched various switches that were running over here into the system that were available to you. Now when we go back here, let's clear the screen. We want to have more information about the processes. So here we have a top command. So this gives a very detailed information about the various tasks or processes that are running in Linux operating system in real time or Unix operating system. So map top. So you will see it will display Linux processes, and it will come with lots of information and switches, which I'm going to explain you in this video just now, and you can read through the documentation for more detail. I will be using some of the switches to give you or help you with some more understanding on the topic. So I'll run the command top. Now you see that we have got a lot of information over here, and if we go over here, we will see that this is the machine, this is the current time, that is 7:50 at the moment here, and this machine has been up since last 14 minutes, one user, and the average load is 0 for last 1 minute, then 0 for last 1 second, 5 seconds, and 15 seconds, 1 minute, 15 minutes, and 5 minutes. So that's how it usually works over here in terms of information on the system on the top. So this is last 1 minute average, 5 minute average, 15 minute. Then we will have more information that there are total number of 135 tasks that are running here. Anything that you see in bold will be the current process that is being run. And 2 processes are currently running, now only one. 135 are sleeping out of 137 because 2 are running. 0 have been stopped, so no process is stopped, and 0 are zombie. So zombie processes are, for example, if you have installed an application and you have deleted an application but you forgot or you did not properly delete the application. So some files or system files are still remaining in the system which needs to be get removed, but they are there, lying there and running. So those processes are known as zombie processes, that they are of no use to anyone. In terms of this value, percent CPU, so this is how long for this user the memory this process is using. So amount of CPU is spending in executing this processes for the current user. The next one is SY, which is the amount of time spent on running the kernel space or the kernel processes, which is our system processes. Then these are nice processes where we set the nice value. You will see here that these are the nice values in the projects. We'll talk about this as we go here. Then we have the idle time. So currently CPU is having 99% idle time. And this is the wait time, which is CPU is having in terms of processing between input-output operations. Then we have hardware interrupt. So amount of hardware interrupts we had and amount of software interrupts we had. So SI is for software interrupts, HI is for hardware interrupts, and ST is the amount of time lost, which is also known as the steal time. Then we have the same information, memory. Again, it's in megabytes. Free, used, buffer, and this is the total memory available. In terms of the information over here, these are the process IDs. There are current tons of processes running. You can always scroll down over here and you can see all the processes that are running. So it said around 137 processes are there, and all the processes have got their own ID and numbers over here, which you can see. Then the next command is user, which user it is running for. So mostly are for root user or system user or Azure user. So you will see many times Azure user will flash on the top. Then PR is the process priority over here, and the nice value. So nice value always ranges from -20 to 90. So lower the nice value, the higher the priority gets for your processes to get executed. If your process is having any specific value, you can always change the nice value for the process to get priority. For example, print command. The print command is 9 in the end. It is number 19. So 19 is the lowest priority. You want it now. You change the nice value to -20. It will get the priority over there. Then virtual is the amount of memory used by this process. This is the amount of resident memory that is used by the process. And this is the amount of shared memory that is used by the process. S basically means the status of the process that it can take. It is idle, or is it sleeping, or whatever is happening with the process over here. So it can be zombie process, it can be stopped process, it can be uninterrupted process, and currently R means the running process. Running process is the top command, which is Azure user, you can see. Then you have your percent CPU, that is the amount of CPU time which has been used by the process. The memory time that has been used by the process, and the total amount of time that has been taken in hundredth of a second, and the command that is running for the process. So let's try to put some stress on the machine. So we'll use the X command or Q command. We'll quit the process. we will come and see this command again. So we'll run some simulation. So I will say sudo dnf install stress -y. We'll use apt as a repository, and it has installed the stress command for us. So now we are going to put stress on VM, that is our virtual machine that is running. So we will just use the command which is going to put some stress onto the system. To do that, we will just use the command. For example, let me show you. So man, let me clear the screen again. I will say man stress. So this is just going to put a load on the CPU. It has got various load on the machine. It's verbose, quiet, dry run, C for CPU, I for IO, M for memory, and VM bytes, etc. So there are a lot of switches over there, and this is where it is saying stress -C, which is the number of CPU, that is the core that you want to put. Do you want to make it quiet? And this will be performing IO operations over there, and it is going to give the switch. So we can say that we want to put we want to generate some hogs, we want to put on the cores, and we want to put the input output operations, memory, we want information verbose, and the timeout is in 1 minute. We can do 2 minutes, 3 minutes. So I'll just copy this command. I'll copy this, and I'm going to press Q, and I'm going to paste this command over here. And instead of 1 minute, I'll put 3 minutes. So now the stress has started. So it has started generating some stress for the machine. Now, when you will start seeing the stress, so it is going to put it on the CPU. It is happening for 3 minutes. It is going to run, and it is going to provide some information for us as the user. So you can generate a lot of stress on the machine. Because we have generated some stress on the machine, we will now be able to get some more information when the stress is completed. So I'll press Ctrl C. I'll cancel this, and I'll just put it for 30 seconds. That is too long, and let's wait. 30 seconds will be quick, and it is running some operations, sending some hogs, and after 30 seconds the system will be available to us. So we'll just wait for 30 seconds. Very quickly it will be there, and we will start having some load that we can see onto the system. There are other ways you can run multiple bash shells on Linux as well. So you can do that too over here. So you can split the cell, or you can split the horizontally, or etc. If you want to, you can do it over here. So let's go and have a look with the top command first, and let's see what the top has generated for us. Now you see that we have some more information. So load information in last 1 minute was very high. Then in last 5 minutes and last 15 minutes. It also generated some more information, generated some more tasks. This is sleeping, none of them are zombie. So just to show it to you, because I generated some stress, it created some kind of information that was available to the user. So let's quit. Let's install a more interactive version of top, which is known as, there are various of them, A top, B top, H top. So I'll install sudo apt install htop -y, and it is installed. So it's already there. So we'll type htop, and now this is more interactive. So now you see the similar information, but this time you're seeing this information in a more colorful and a more interactive way, and it fully supports mouse usage. And you can use function keys, other values which are displaying over here. So this is totally up to you. So if I press Q again, and if I again generate the stress onto the machine, but this time I will do it only for 10 seconds, not for long, so that we quickly come out of this. And this is going to generate some stress quickly, and it will give you some output onto the system. So it has been signaled, and let's go and run htop, and you will see more information that has generated over here. CPU usage, memory usage, then load average for last 1 minute, 5 minutes, 15 minutes, one process is running. These are the number of tasks, this is memory used, etc. So it's a similar thing, but yeah, it is a more interactive version of the system. So you can use this if you want, or you can use the simple command over there, which you can also choose it. So this is for IO operations, and this is for your main operation. So you can explore this at your end now. So I hope this makes very clear to you what are the processes and what do they mean. We will just try to run some top command with some switches. So let me clear the screen, and I will say top -d. It is going to display at a regular interval, so that if I say 5, it is going to update the information now every 5 seconds. So you will see that there is more change in information every 5 seconds. So -d as a switch helps you to generate the information in regular interval of time. Let's quit. The next command, we want to check for any specific process ID. So for example, process number 11. So let's say top -p and 11. It's only going to display process number 11. And you can see about it. If you want to look for a specific user, so we'll do the same. We will use -u as a switch, which is for user, and the username is Azure user. And now it is showing all the processes that are running for Azure user only. Quit. If you want to see the number of iterations for the users, so for example, I want to see 3 iterations or 2 iterations for this user, I can say -t3. So 3 iterations, -n. It will show you 3 iterations only, and after that it will kill. So any changes, so you must have seen that there were 3 changes that happened, and after that it killed. So it did not go endlessly, it just showed you the last 3 iterations, and it quit from there. Then you also have batch operations and all, which you can try at your end, and go back to man top and learn more about it. So let's clear the screen. A couple of more commands. One of them is df. Df basically shows about disk space. So if I go and say man df, it is going to show the disk or the file system space usage that you can see onto the system, and some switches are over there. So please refer them. We'll be using them. So first command is df. It is going to show you that these are the file systems. Data is stored in the form of blocks, which is 1 kilobyte blocks, 1024 bytes. How much is used, how much is available, and how much is actually used. So device root is mounted on root. Temps are mounted on these different directories. EFI, which is related to boot, is mounted in boot. Then SDA16, which holds the boot, is mounted on boot directory, and SDA15, which boots the system, is mounted on EFI subdirectory in the boot directory, which is available in root. And this is your directory which holds the data, which is mounted on the mount folder. Now basically mount is important because it needs to know which directory you are going to mount the file system onto it. The blocks by default size is 1K, but you can use various switches. So for example, if you use df-h, it will give you more information which is more specific, much more human readable over here, which gives some data over here into the system. Then you also have df-a, which is all the file systems. So these are all of them which are available in this machine, which are displayed to you onto the system, and where they are located or mounted and what is their name. Then you have df, which is -t. It will show you the type of file system, which is very important for you to know, because we had ext file system, ext2, ext3, ext4, xfs, btrfs, etc., etc. So you can just say df-t, that is the type, and now it is telling you that it is of type ext4 or tmpfs or whatever the file system it is, or vfat, which is here, or ntfs, what kind of file system it is or what kind of format it is. These are basically limited by the operating systems, their types, so, and their features and compatibility. So you may not see all of them, but you may see most of them. Then you want to have more information about it. So command is df-i, which is information. It gives you one important information is inodes. So you must know what inodes are. Inodes are basically the data structure. Inodes are basically the structure or the data that holds information about the files and directories that are stored, like their size, who is the owner, what are the permissions, what are the timestamps, etc. And remember, the number of inodes you have, that those many number of files you can only save. If you have got 10 inodes, that means only 10 files you can save. If you've got million inodes, you can save million files. But if you save files of smaller file size, for example 1 KB, 10 files, that means you've used your all disks. Even though if your disk is still lying empty, you cannot store the files because there are no more inodes available. So be very careful. It can be important if you have got too many small files. You may need to release them. The more the inodes you have, the more the files you'll be able to save. And if you want to have the output in Unix based or POSIX based format, that is the standard for Linux Unix based system, command is df-t, which will give you slightly similar information, but this time it is going to give you file system. It's in the form of 1024 blocks, how much is the used capacity, available capacity, and so on. You can also mix and match them like this. -t is for time, h is for human readable format, and it's going to give you some more information. You can also add the switch I, which is going to add inodes now. So you can also mix and match these switches over here. So I hope this makes clear to all. The next command is du. So man du. Du is about your file space usage. So estimate file space usage for the files, and again it has got some important switches, which I'll show you few of them, but yes, you can check your file space usage and types with these commands. So command is du. It is showing you in the current directory, which is ls, you have got certain directories, which is .ss. I'll show you ls-a is all. You see there are a lot of directories like config.ssh, which are hidden files, config proceps, which is there, config cache, and total number of files or total number of data that is space used is 136K or whatever it is. But it is just showing you the total. We are not seeing all of them, which also I'll show you shortly. So here it is. So if you use du -a, this is how your 136 bytes are, or kilobytes of data is being used in your child directory. See, it is showing here child. Wherever you are, that is where you are. Then you have more details. If you want to see -as, it will also show the size of the each item. Cannot use both, so we'll use s. So total value is 136, which is the size of all item, total size. That's why it did not work with the switch A. Then you have C, which can produce the grand total. that this is how this is being used, 136. But again, if you want, you can use A and it will give you more information. Similarly, the only thing it does, it adds the total. And then lastly, I will also show you ls-la. You will see it has got certain directories. Now there is a config directory. If I say cd config over here, .config, sorry, and I do ls, there is another subdirectory which is htop and process. So if I do cd htop and I do ls, there is a file which is holding some data. Now if I go back to where I belong to, which is here, and I clear the screen and I say I want to view all the files up to maximum depth of 1. So I will say du -- max depth is equal to 1. Now you will see that the config is showing only up to 1 directory level. If I change it to 2, it will show up to 2 level. If I change it to 3, if there is any subdirectory after these, it will show you at that level also. Let's do it over here and I say slash. So now everything is showing up to 3 levels. You can see maximum. I press Ctrl C and I say let me clear the screen first, and I say I want to see all the file usage in the root only up to 1 level. This is quick. So only up to 1 level, and it is not showing certain information because permission is denied. I'm not using this command as a sudo user, but it is showing you the total value over here. You can also use the command with here as -c switch, which is this is the wrong command, which is going to show you total also in the end. But this is how your bytes are used. So lastly, to conclude, we have kill command. So man kill basically kills the processes. It sends a signal to a process. So there are a lot of signals that are available over here. So for example, I will quit and I will say clear and I say kill and I'll say list the signals. So these are 64 signals that are available and these signals are sent to the processes. So if I do ps, I'll see I've got some processes running. If I say ps-e, I have got some other processes running. Do not kill the processes if you don't know about them. They can be dangerous, very dangerous. So for example, I'm going to run a command which is sleep 2. It will hold the terminal for 2 seconds, but it does not allow me to do anything for 2 seconds. Now if I say I want to make it sleep for 200 seconds, but you keep on sleeping in the background, I again say this time 2000, keep on sleeping in the background. I again say 20,000, keep on sleeping in the background, and now I say ps. So these are the processes. I want to kill process number 2151. So command is kill -9. 9 is the signal. So here it is. See, kill -l. 9 signal is to kill the process. So I'll just use the command kill -9 and the process number is 2151. Killed. And now if I do ps, you will see killed sleep 20,000. It is showing you over here in the system. You can also print a particular process ID. You can kill the processes. This is forcefully. So -9 basically forcefully terminates the processes. And if you want, you can also print a particular process ID. Or you can use other switches. But just to let you know that kill command is very dangerous. Do not use it if you don't know about it. It can kill any running system processes, which may create problems for you at a later end. If you have any questions over here, feel free to reach me. I'm sure I try to make things, basic things, understandable to you. Thank you for watching this video out. Have a nice day.